Fine. See, in this periodic table, as I told you that there are 18 groups and then there are 7 periods and there is a particular shape of periodic table. Now the question is, why do we have that particular shape of the periodic table? Okay. So now what we will do is we will use the concept of electronic configuration and we will create this periodic table. Okay, and we will see why we are having the shape that we are having right now. So in the last class we discussed that there are 18 groups. Okay, and then there are 7 periods. So let me make a matrix of 18 by 7. So we will like start from here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So I am making a periodic table over here, and you will be surprised to find out that we will get exactly how the periodic table is looking like, and by utilizing the concept of electronic configuration. Okay. So here we have thus 18 groups and 7 periods. Okay. Now what we will do is we will mark these periods with principal quantum number. Okay, these are the principal quantum numbers. And now let's go back to the electronic configuration, and I would like to know from you guys. Sesa center beta, I will explain it to you. By the time I will finish with this period table, you will understand why there are 7 periods, don't worry. Okay, because now I am getting into the depth of it. Okay. So now I would like to ask, what is the electronic configuration of 1? What is the electronic configuration of atomic number 1? Can you guys tell me the answer? What is the electronic configuration of atomic number 1? Very good. The answer is 1s1. So how will you read 1s1 now? You will say 1 is the number of period. Okay. S is the block. And this is the group. So what you will say? You will say 1s1 means that this element is in the first period, S block, first group. It is in the first period, S block, first group, right? Okay. So when I am saying it is in the first period, so it should lie over here. It should be in the S block. Okay, so let me make the S block. This is the S block. Okay, and in S block it is in the first group. So say this is the first group, this is the second group. Okay, so atomic number 1 will be written over here. So it is 1s1. I repeat, it is 1s1. Okay, so when I write atomic number 2, it will be 1s2. 1s2. Okay, now when I write 3, it is 1s2 2p1. So you have to check now. In this case, you have to check this 2p1. So 2p1 means I marked it wrong. 2s1, sorry. So 2s1 means second period S block first group. Second period S block first group. So this is 3. Same way 4. Now when I talk about 5, it is 1s2, 2s2, 2p1. Now what do you mean by 2p1? 2p1 is second period P block first group. So now I need a P block. Okay, so let me mark this 1, 2, 3, 4, 5, 6. Let me mark this as the P block. Okay, and this is 1, 2, 3, 4, 5, 6. So this is atomic number 5. So that way, if I write atomic number 10, it will be 1s2, 2s2, 2p6. So 2p6 means second period P block 6th group. Zoom out करेंगे please. Second period P block 6th group. So second period P block 6th group. Okay, this is how we are going to fill the elements in the periodic table. But there is a problem. Now you will ask me, sir, what is the problem? See, my dear friends, atomic number 2 and atomic number 10 have something in common. 2, 2, 8. Their outermost shell is complete. If their outermost shell is complete, means they will behave like noble gases, they will behave inert, and all those elements who are behaving inert should lie in one group. Should lie in one group. So 2 and 8 should lie in one group. But they are not lying in one group, they are lying in two different groups. So what am I supposed to do? I need to put them in one group, which means this P block is not taken rightly. This is wrong. Let's change. So where should I take P block? Akkad bakkad bambe bo, 80 90 pure 100. Should I do like that? Okay, let's take a better assumption. What is a better assumption? All those elements whose outermost shell is complete will be placed in the 18th group. So 2 comes over here, 10 comes over here, so 9 comes here, 8 here, 7 here, 6 here, 5 over here. So this means that this is the P block. Okay, and if this is the P block, then all these blocks which are empty, I don't need them. This is wrong. I don't need. Yeah. Tell me. We are getting nearer to the shape of P block, huh? And this is group number 1, this is group number 2, group number 3, group number 4, group number 5 and group number 6. Okay, fine. So now I start with atomic number 11, which is 3s1, 12 is 3s2, 13 is 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. Please check 18. Octet is complete, right? And 18 is 1s2, 2s2, 2p6, 3s2, 3p6. And as I've told you people, that we have to look at the last one. So, third period P block, sixth group. Third period P block, sixth group. Okay. So, again I don't need this part. Right? Now 19 is 4s1, 20 is 4s2. Let us see what is 21. 21 is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Which means I require the D block now. Do I have any choice? No, I don't have any choice. Left S block, right P block, so I have to put D block at the center. Okay. So 21 will start from here. So likewise we have got 22, 23, 24, 25, 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36. Likewise 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57. Okay. Let us check what is 58. I'll check it over here. Now see, after 6s I cannot go to 5d, 4f will come into the picture. Let's count. 2, 4, 10, 12, 18, 20, 30, 36, 38, 44, 54, 56. So now I need this for 57. This one I need for 57. So over here there is a small exception. 57 we don't simply give to 4f. First we go to 5d and we write 5d1. 5d1 is for 57. When I say 58, so it becomes 5d1, 4f1. I repeat once again. When you are talking about the F block is embedded in this particular group. Okay. So to start with this particular group and keep the periodic table in a right symmetry, for atomic number 57 we have to make an exception. That exception is that we have to fill 5d1 over here, and then 4f1 starts. Okay, so the electronic configuration for 58 will be 6s2 5d1 4f1. Okay, this is how we will write the electronic configuration for F block elements. You can count once again: 2, 4, 10, 12, 18, 20, 30, 36, 38, 44, 54, 56, 57, 58. Please remember this part. So over here 58 to 71, we have got what we call as lanthanides. Okay, this is an exception, please remember. So now this will be 72, 73, 74, 75, 76, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89. Now same way, (92) 103, they are termed as actinides, and this whole is termed as F block. F block, okay. So this is 104, 105, 106, 107, 108, 109, 110, 111, 12. Okay, fine. So this is how you have got S block, you have got P block, you have got D block, you have got F block, right? And now if you write down the configuration of each block, for S block it is NS1 to 2. For D block it is NS0 to 2, N minus 1, D1 to 10. Okay. For P block it will be NS2, NP1 to 6. For F block NS2, N minus 1, D0 to 1, N minus 2, F1 to 40. Okay, I will share all the exceptions which are there with you guys. Fine. But before going ahead with this part, now you have understood 7 periods, 18 groups. Have you understood this part? Now certain exceptions that I wanted to tell you for electronic configuration. See, chromium 4s1 3d5, copper 4s1 3d0 3d10, silver 5s1 4d10, gold, palladium, okay, fine. Now I am giving you the electronic configuration of this F block elements. So 58, please check over here for 58, it is 6s2 5d0 4f2. Okay. Okay. Then for 64, 6s2 5d1. See, over here you are getting 5d1 and 4f7. Please remember the configuration of the elements that I am telling you. Okay. Now for 65, now this will again be exceptional because again you have got 0 and you have got 4f9 now. Okay. Now 65, let me just check once again. You got 56. 65, yes. For 66, okay, 6s2, 56, 56 plus 14 is 70 plus 71. In fact, 66. This is okay. So they can ask this, this, and this. You please write down all these configuration which I am telling you. If they would ask a question, they can ask a question straight from here. You have to mug these up. Specifically the medical batch. Okay. They can ask you all these. No. So you write 113, 114, 115. Hello? Okay. Fine. Okay. Okay. So you have got all these elements in front of you. You've got all these elements, right? Let me show you certain things now. Let me, first of all, you know that why periodic table is looking like this, first thing. Now, how to calculate the electronic configuration very quickly, or what if a question is given to me, write down the quantum numbers of the last and outermost electron of atomic number 109. Suppose you have to solve this question and I give you a time of 10 seconds only. Okay. So your time starts now. Okay. 5, 4, 3, 2, 1. 10 seconds are gone. Anybody got the answer? Has anybody got the answer? Now you guys must be thinking, sir, we cannot get the answer so very fast. How come we can calculate? Chalo. Let me show you how you can calculate it out. Ask me the electronic configuration of any number written over here. But we will do it one by one, okay? We'll do it one by one, okay. So I said 113. 113 is 7s2, 7p1, which means that the element is in the 7th period, first group of p block. 7th period, p block, first group. The second that has been asked to me is 74. The answer is 6s2, 6p4, which means it will be 6s1, 6p5. Anyways, it is in the 6th period, D block, 4th group. 6th period, D block, 4th group. 6s2, 6p4. The next number is 108. Okay, so this is 7s2, 6d6. 7s2, 6d6. 7th period, D block, 6th group. 7th period, D block, 6th group. Okay. Next number given to me is 72, 7s2, 6d2, 7th period, D block, 2nd group. 6th period, D block, 2nd group. 6th period, D block, 2nd group. Next is 116, 7s2, 7p4. 7th period P block 4th group. Next is 109, 7s2 6d7, 7th period D block 7th group, 109. Next number is 83, 6s2 6p3, 6th period P block 3rd group, 6th period P block 3rd group. Next number given to me is 48, 5s2 4d10, 5th period D block 10th group, 5th period D block 10th group, 48. Next number given to me is 89, 7s2 6d1, 7th period D block 1st group, 7th period D block 1st group. Next number given to me is 60, I cannot see 60 written over here. The next number given to me is 118, 7s2 6p6, 7th period P block 6th group, this is 118. Okay. Hamesha says 45, 5s2 4d7, 5th period D block 7th group, 5th period D block 7th group, 45. Okay, 82, 6s2 6p2, 6th period P block 2nd group, 6th period P block 2nd group, 6s2 6p2. Now I will tell you 109. See, 109 is 7s2 6d7. Now listen to me very carefully. See, this is the outermost electron because the value of n is maximum. So this is outermost. This is outermost. Okay. The last electron is filled over here, so this is last. Now the quantum number n is equal to 7, L is equal to 0 because it is S, ML is equal to 0, MS is equal to plus minus half. N is equal to 6, L is equal to 2, ML minus 2 to plus 2, and MS is equal to plus minus half. These are the quantum numbers. Now let me tell you the trick. See, look at this group 18th. Okay. Now you have to remember these atomic numbers as if they are a telephone number of your friend. 2, 10, 18, 36, 54, 86. If you want 118 as well, but it won't be needed, but anyways. Now see, the electronic configuration of this is 1s2. Now you see, it will flow in a very simple manner. 2s2 2p6, 3s2 3p6, 4s2 4p6, 5s2 5p6, 6s2 6p6, 7s2 7p6. Okay. So if you see, it's simply flowing down so easily. Now somebody asked me, sir, what is 118? So I said 7s2 7p6. Then somebody asked me, sir, what is 116? So how do I get 116? Out of 118, you subtract 2, right? So you will get 116. So out of the 7p6, subtract 2. So the answer will be 7s2 7p4, right? Let's take another example. You asked me 83. What is 86? 6s2 6p6. To get 83, I have to subtract 3. So subtract 3 from here. So it will be 6s2 6p3. Now tell me. Clear? 82. You have to subtract 4. So 6s2 6p2. Now you have to tell me the configuration of 52. Tell me what will be the configuration of 52. So all of you have got it. Now the second trick. This was the first trick. Now I am going to give you the second trick. Atomic number 30. Remember these numbers: 30, 48, 80, 112. 30, 48, 80, 112. 30, 48, 80, 112. Okay? Mark up these. Now see, 30 is 4s2 3d10. 48 is 5s2 4d10. 80 is 6s2 5d10, and 112 is 7s2 6d10. Okay. Now see, you wanted to know 109. I have to subtract 3 from here, so I will subtract it from D. 7s2 6d7. You wanted to know about 45, so I will subtract 3 from 48. 5s2 4d7. You wanted to know about 74, so out of this I will subtract 6. So 6s2 5d4. Okay. Now you people tell me, what is 77? See, for D block it's very simple. You have to remember this. This is 30, 48, 80 and 112. Okay. Now see, this is the outermost electron, outermost, and this is the last electron. Okay. So suppose you have to find out 109, 112 you know it is 7s2 6d10. 109 you have to remove 3 electrons. So you will not remove from here, you will remove from here. It will be 6d7. That's what I taught. Okay, fine, great. Now certain theory parts. Everybody has copied it down, na? You all got the trick? Great. Now some theory part, which you have to keep writing now. See. S and P block elements are termed as representative elements. D block is transition elements. F block is inner transition elements. Okay. Electronic configuration or inner transition or rare earth elements. Okay. Now there is a term called transuranic elements having atomic number greater than 92. They are termed as transuranic. Group 13, sorry, group 1 alkali metals, 2 alkaline earth metals, 13 boron family, 14 carbon family, 15 nitrogen family or nicogens, 16th oxygen family or chalcogens, 17th halogens, 18th is noble gases. Okay. Clear to everybody? They are called as nicogens as they are generated from the nitrogen containing compounds. Chalco means oxides, generated from oxides. Halogen generated from water. Got it? That is why they have got these names. Now, group 12, volatile metals. Which are the volatile metals? Zinc, cadmium, mercury. Okay. Group number 11, coinage metals. Copper, silver, gold. Group number 10, catalytic metals. Nickel, palladium, platinum. Iron triad. Iron, cobalt, nickel. Okay. There are 11 gases in the periodic table. Hydrogen, nitrogen, oxygen, fluorine, chlorine, helium, neon, argon, krypton, xenon, radon. Two liquids, though there are two more, mercury, bromine. These are liquid. This is liquid metal, this is liquid non-metal. Apart from this, cesium and gallium are also liquid at 30 degrees Celsius. So in many countries, rather I should say African countries, they will always be in the liquid state. Right? Rest all are solids. Rest all are solids. Okay? Third period elements. They are termed as typical elements. Coinage metals are not named on coin. Coinage metals because we used to make coins out of these metals. Okay. Janendra is asking, is group number 12 considered as transition metals? No, they are not considered as transition metal. They are kept over there to maintain the symmetry. Okay. Actually, nicogens have come from a Greek word nigen, which basically means that something that chokes you. So if you are given excess of nitrogen, it will stop the flow of oxygen and will choke you. So because of the choking property of nitrogen, we call it as nicogens. There should be a T over here. It's nectogens. P-N-I-C-T. P-N-I-C-T-O-G-E-N-S. Nectogens. Fine. Next thing. One, two, three, four. 5, 14, 32, 33, 51, 52, 84, 85. These are metalloids. On the left hand side all are metals, on the right hand side all are non-metals. Okay? If you want to write them down, this is boron, silicon, germanium, arsenic, antimony, tellurium, polonium and astatine. These are the metalloids which behave as metals as well as non-metals. Okay. So these all are the metalloids. On the right hand side of metalloids you have got non-metals here, and on the left hand side you have got metals. Okay, fine. Now I am rubbing this part. Now in this chapter we have to study about atomic radii. Now in atomic radii we will be talking about ionic radii also, covalent radii, van der Waals radii, and hydrated ionic radii. So I will talk about all these. After that we will be talking about ionization energy, after that we will be talking about electron affinity, then we will talk about electron affinity is termed as electron gain enthalpy, talk about electronegativity, then talk about Slater's rule, then we will talk about diagonal relationship, okay, and lastly we will talk about metallic and non-metallic character. In ionization energy we will be talking about penetration effect, then we will be talking about screening effect, then we will be talking about inert pair effect. Okay.